All right, hello and welcome to the first session of Internet as a Platform, Programming as a Medium. So this will be a four-session seminar in which we will be working with JavaScript coding and the Internet and artistic collaboration. So I'll pass it on to Manny, who will give us a better introduction anyways. He's an instructor. So, yes, Manny.
Okay. Hi, everyone. My name is Mani. I write code. I make things. I try to make art. I try to make things that I would like to call art. I'm not sure if I succeed, but I'm very excited about this class. Mostly because over the past few years, I've been experimenting with browsers as kind of the white box, if that makes sense at all. Creating experiments and interactive installations that run entirely in the browser, and I'll be talking a little bit more about that and its implications and things like that. So I'm not sure if you guys got the readings that I sent over a little bit earlier, maybe.
Posted them on Classroom. I know Olivia got them. Jocelyn, did you get them? I mentioned it. Okay, I can't hear you. I don't know if it's the microphone in your headphones not working.
I think she. Okay, so Olivia is muted, but Jocelyn is not mute.
No,
Can we use the
sorry.
chat?
We can use the chat for now, and I'll keep going. I'll use the chat to help her.
All right, sounds good. There are some readings that I mostly scanned from different books and put together and sent it over. It's nothing too kind of rigorous as far as theory goes. It's mostly just creating the framework on top of which we'll be building our class. More or less expect this class to be hands-on, expect it to be kind of only providing the structure that you need to get started with your projects, and at the same time working on chops that you can use directly in creating your own work. I would love to kind of start thinking in kind of a structure that you can use to kind of develop your own ideas. I would love it if you could, if you would kind of come up with your own projects and talk to me about it, and we can together figure out what you need to get your projects done. There are 3 projects that I've defined for this class. There's a 4th one which is optional. There is a lot to cover, so as far as programming and different concepts and things like that goes, if you do have experience, that's great plus. If you don't worry, it's fine. No programming knowledge is assumed, so we can work together to figure things out. That wraps it up for the readings. There is a set of slides that I put together, and also just a large compilation of my mind barf that I put together when I was kind of preparing for the first session of the class. That's hosted on this thing called HackPad, which is a super ad hoc, non-formal Google Docs thing, which is, I believe, what Google Docs should have been all along. And so this is kind of all the notes for the first session. I'm going to paste the link for the... oh, well, look at that. One step ahead of me. No, that's great. So if you click on the slides, we'll be able to go over the slides together. I might ask you to mute your microphones and play some videos here and there and some slides that I've embedded just to get a better sense of what we're talking about, and I'll be rambling on it all along. Yeah, that's it. So if anyone, oh, actually, I would love an introduction from everyone else, except if your mic is broken or something doesn't technically work.
I'm Olivia. I just joined the new center recently and just took the Art and Its Reason seminar, so I was hoping that it would coincide well with this. Yeah, I've done a little HTML, but I've never really done coding, so I'm pretty excited to learn some stuff. And I just started doing digital art recently. I studied sculpture formally in school, so
Awesome.
yeah, I'm really excited about this class, that it's hands-on, and yeah. Mm.
All right. Sounds great. Sounds great. Well, I know Nushin, but please go ahead and introduce yourself.
Hi, I'm Nushin. I'm an artist. I also recently joined as a member, joined the new center. I have done general HTML, CSS, and a little bit processing, and I'm super excited about this class.
All right, Jocelyn. No, I wish I was better at reading lips.
It might work if you if you restart the browser, if you come back into the Hangout, Jocelyn, or look at this. I sent a link on the right that has troubleshooting tips. You can put, if you want to put your bio in the chat on the right as well, you can do that.
All right.
We'll get it solved somehow. We have 2.5 hours. We have 2.5 hours. It's a long time to solve this problem.
Yeah. All right, that sounds good. Okay, so without further ado, let's jump into slides. All right, so Internet as platform and programming as medium. It is the first step of even start thinking about this thing is to kind of start thinking about the process and think about digital art and its affordances and what it can provide for us and how it's different from other forms of art, other mediums, and other kind of ways about thinking about the process of creating art. So the first session we're going to be talking about procedural thinking and programming fundamentals. So I want you to start thinking about externalizing a process that a machine can follow step by step to reproduce in more or less a high or low fidelity a kind of a system that you as an artist have the authorship to create. In other words, we're going to be looking at the passage from artist as the creator of object to artist as the creator of process. And then we'll be using computer as this kind of, in a biblical sense, it's before day one, before anything exists, and you're the God, and you create all these rules, and you just let it loose, and then things just happen. So it's like this field that you'll be planting the seeds of process in, and the machine will carry them out for you. We'll be looking at some background about digital art, kind of going over a very brief history and the key turning points in the past. Oh man, it's been over 50 years now. And even before that, the role of process in the creation of artwork, and then we'll take it from there. What else did I want to say? There is a few logistics things that we want to take care of, and I'll go over those real quick. So I moved forward to slide 1. Tony, do you want me to share my screen for the slides, or should I just say like, all right, next slide or previous slide? I don't know how that works.
You can share your screen, or we can all use them. I mean, to me, sure, if we're going to be all on a different screen anyways, looking at them, you might as well just share it. Yeah.
All right, screen share. All right, entire screen.
Yeah.
Or, you know what, maybe just a browser that has my... Sweet. All right, look at that technology. Okay. So we're gonna, like I said, history, and we're gonna have a bit of a discussion, and then we'll jump into code. I really didn't know what to expect as far as kind of programming knowledge goes, so I designed it in a way that it starts very, very basic, and I'm hoping that visualizing the concepts that I'm going to be talking about, I put together some weird GIF animations, and I was like, I'm going to experiment with GIF animations as teaching tools, just to explore different programming concepts. And then towards the end of the class, we'll actually use these accounts that we'll be creating in the next slide to start writing some code and kind of getting a feel for how things work. And then at the end of the class, the assignment that I would like you guys to think about and work on would be exactly describing the process of a piece of procedural artwork that you would like to make. You don't have to write any code if you don't want to, or if you don't feel very comfortable with for next session, but at least I want you to get in a mindset of creating kind of process for the work. So the general structure is that we're going to be going over material. I'm going to take it one session at a time. So I'm not sure if for next sessions we're going to have like, I don't know, I have like 50 slides for today. I'm not sure if next sessions we're going to have as many slides. I would actually like to move forward to a more kind of hands-on thing. But anyways, we're going to be talking about the material. Then we'll go into live coding, and then discussion. We might swap out 2 and 3 based on how much time we have and how many questions you guys have, or whatever you guys want to talk about, or based on the readings and things like that, if anything comes up. So first of all, I want you to click on these links in the right order. You would have to create a GitHub account. Now go ahead and do that now. Sounds good. So go ahead and do that. Just create a GitHub account with your email. It should be pretty straightforward. Just a very quick intro to GitHub. What it does is essentially, historically, creating software has been challenging in a sense that, first of all, software is very, very easy to grow out of hand in terms of complexity and so many different parts that come into play. So naturally, you go from a one man sitting in a basement type like Google, and how Google started in a basement with 2 people sitting at their computers, to large teams. When I say men, I generally refer to human beings. I don't want to be like gender biased when I talk about this, and especially in tech that I work, it's kind of like a problem and a weird thing that I deal with every day. So forgive my political incorrectness if I say things like men. Software is created in collaboration with large groups of people, and they needed a way to effectively collaborate with each other, and versioning becomes very problematic because if I have a software that consists of like maybe 200 files, and this is all source code, and my colleague wants to make a change, what if my colleague overrides my changes, or I override somebody else's changes, and so we step on each other's toes. So that's why a concept kind of came into existence very early on in creating software for teams called version control, meaning that everybody has a copy of all the code in their machine, and they use this kind of term called commit. So you make a change, you commit to it, and everybody else sees your commit, pulls it down to their machine from a remote server, and based on that, the machine will kind of mediate and be a protocol for you so that you don't step on each other's toes and you can work collaboratively and you see each other's changes in real time and work like that. So GitHub is essentially a very modern, contemporary, very easy to use web platform that allows you to do that. I don't want us to get too tangled up into the nitty-gritty of version control and kind of using that, but it's really, really good as a programmer to have a GitHub account. And biggest reason is that a lot of different services that you use, like in-browser code editing environments, such as CodePen, that is on bullet point number 2, that I would like you to go ahead. If you're done with making a GitHub account, go ahead and create an account on CodePen. Is that a lot of these services can easily just help you on board with a click of a button if you have a GitHub account. And at the same time, when you get a little bit more savvier and when you kind of start navigating the open source landscape, GitHub is essentially the place to be, because you can find source code for an automated pet feeder for your cat, and at the same time, like, find source code for I don't know, creating a rocket operating system, and everything in between. So it's really useful. And as we go forward, and as we talk about what we're going to be building on as artists and programmers, you will see how much we rely heavily on open source projects. And so most of the open source projects that I've come across have been hosted on GitHub. So again, yet another reason to create a GitHub account and get the ball rolling. So if you created a GitHub account and created a code pen, and I'm going to pause and ask if everyone's on the same page in a minute. Next, you can do the number 3 after the class is over, because we're not going to be using this in class. However, we'll be using CodePen during the class time. I would like you guys to have a code editor locally that you can use to write code. But I don't want us, again, to get tangled up in complications that local like development environments on your machine might cause. So we're just going to stick with CodePen, which is online and no strings attached, and it comes kind of out of the box in the browser for you, so you don't have to worry about anything else in your local environment, and we'll just take it from there. For the last project, which includes computer vision, algorithms, and things like that, I would have to create a server that you can then write code for, and we'll get to that when as we move forward. So there is a chance that I might ask you to use the code editors that you will download for whatever operating system that you have to work on the last project, but we'll cross that bridge once we get to it. So how's the status? Did I manage to distract everybody while they were trying to get work done? Do we have our CodePen accounts? All right. Sweet.
Yes.
Sweet. Jocelyn. All right. I'm hearing Jocelyn. I'm not hearing. I'm seeing her talk, but I can't hear.
You might need to, Jocelyn, you might need to restart, if you just installed the plugin, you might need to restart the browser and then come back into the Hangout. It'll be available.
All right. We can pause for like a few minutes, because I don't want you to miss out. Is that fine? What do you? Yeah. All right. Okay. Go do your restarting. We'll see you in a little bit. All right. Okay. While Jocelyn's away, before 2 sessions, take as much time as you want, exploring these concepts that I talk about. Do reach out to me often and early if you have questions. Learning a programming language is essentially just learning a language. There's nothing really different between learning a natural language and a programming language, in a sense that they both use kind of like low-level modular concepts to describe high-level kind of human concepts that you can kind of communicate with other humans, and in this case the machine. And in the same way that I totally don't remember any French, but I was super good at one point, if you don't practice programming languages, you'll just forget them. So practice and ask questions, and get in touch with me, and that's my email. And let's see if Jocelyn can hear us and talk to us.
Can you hear me?
Yes, I can. That's awesome.
Yay.
All right. All right, we're in business.
Nice.
All right, cool. Did you get a CodePen account?
I've actually lost all of the links that you had sent earlier in the class.
All right, I'll put them back. Oh, there it is.
Okay, so let's move forward. We'll get to CodePen if we need to at a later time. Okay, so All right. We'll be breaking down the class into 3 or 4 different sections. The first one is going to be about procedural art and externalizing your process as an artist, and going to be talking a little bit about this. The second session would be actually the third session would be. I'm sorry, the second session would be about simulations and how you can create very simple ground rules in your computer program to create simulations. So in a sense, we'll get a little bit into emergence and how kind of low-level, simple rules can create really complex behaviors and systems. And we're going to look at how we can program those and how we can use those to create work and how we can explore that and what it means from a conceptual standpoint. And I would then love to hear from you guys and what you think. After that comes digital collages. So we'll be looking at how we can algorithmically manipulate images. So imagine like if you want to create mashups or collages or anything like that, we're going to be looking at how to write algorithms to manipulate images in real time or otherwise. And the last but not least, we'll get to computer vision, and that's essentially how we can kind of engineer experiences in the browser that use computer's eyes as the input. And we're going to be looking at how we should start thinking about creating experiences and creating engaging kind of interactions between man and machine, and how we can turn that from kind of a non-natural, so to speak, mouse and keyboard clicking and touching and things like that, to something more like more natural, like the machine perceives your movements, the machine sees your face, the machine can feel your emotions based on certain algorithms that it runs to deduce your feeling and your mood. And we'll see how we can use that as an input and how you can map that to your own output in your work. So it's really, as I move forward and as I talk about these things, you will see that we're constantly moving between input and output, and that's what computers are all about. They're essentially very complex, fast input-output systems, and creating digital art would kind of like have us start thinking in that mindset. So let's move forward. So we talked about all that stuff. The second one is really funny because when you start like learning programming, first you won't know what to ask. You'll be like, what is a thing that I can put here that does the thing that I want to do? But then as you move forward and as you look at examples and as we talk about different things, you'll hopefully get a better kind of understanding of how to formulate better questions. And asking the right question from Google will get you to your answer real quick. So that would be something, kind of like a skill to develop in and of itself. We talked about the rest. So let's talk about appropriating technology. When we talk about digital art, and that's something that I've had to talk to people who were kind of less familiar with, with digital art, which is kind of weird because as we will move forward and we'll see that people have been making digital art since the 50s, and for God's sakes, it's 2015. But it looks like sometimes it still needs defending. 3 years ago, I was giving a workshop in Tehran about augmented reality and its creative applications, and people were interviewing me and they'd be like, so what does this mean? That like this is so easy, you just like create something, write some code and you just put it there and the machine does all the work. This is going to kind of destroy the whole aura of art, and it's not really art because it's done with computers and things like that. And I was like, listen, this is nothing new, and if you have a hard time wrapping your head around it, it's your problem. And artists have been appropriating their kind of contemporary technology as medium since much earlier on. When you look at, when you look at painters centuries ago, as chemistry moves forward and as scientific kind of improvements give way to engineering better material for the artist, they pick it up at in a blink of an eye, and they start using it and appropriating it as medium. It's the same thing with photography at the turn of the century, not turn of the century, 1826, we're looking at it right here. Technology starts to develop, basically different phenomena start start developing as theories and find their way into labs, and then they turn into engineering and they go into mass production. And artists have this kind of like tendency of seeing and foreseeing interesting turns and interesting trends in technology that will eventually subvert the way that we think and the way that we perceive and interact with the world around us. And they're really, really good at picking it up really early on and be early adopters of technology, but appropriating it as medium, which is really the same thing if you think about something like photography. And programming in computer science is really nothing different than that. So you go from something like this to a established art form like photography, which is again the same process that I mentioned. So this is UNIVAC. I'm assuming sometimes in the 50s, and this is really daunting and really kind of weird to look at, and it's really strange. But artists didn't really think so. They would hire, they would actually buy, they would rent these machines in different universities or research centers, and they would pay a fee just to be there and experiment with these things. These are really, really slow and very, very large machines, obviously, but people started kind of like getting into exploring this as a medium very early on, in the same way that different chemical material for painters, and then later on photography for photographers. Okay, so this is Munford Moore, one of the earliest kind of adopters of digital technology and programming as a medium, and that's a large plotter. So he would essentially write out the instructions for creating generative art, and the machine would run it and print it out. And he continues to be one of my role models. I will never be able to grow a mustache that thick and that epic, but we'll see. So this is one of the earliest works in a series from 1977 to 1987. If you guys are in New York, definitely do check out Bitform's gallery, which was in Chelsea, and I believe it's in Lower East Side now. I have this kind of like compilation of all the notes. I'm gonna add that right there. You guys have the notes. It helps to kind of have it open also. I just pasted the link there if you don't have it. So moving forward, programming as medium. So this is in Paris, 1971, and this is one of the kind of turning points in digital art history. This is an exhibition called A Programmed Aesthetic, and the main question in this exhibition, which was kind of like a premiering exhibition for digital art, along with something called like other endeavors such as Cybernetics Serendipity, which I believe was in London. And so pioneering digital artists start kind of showing their work, and obviously people and art lovers and whoever are like, well, this can't be right because art is human, and you get to this kind of like whole issue of them not really understanding what cybernetics is, and this is at the same time that cybernetics is being born, and important papers that are being written on it by people like Norman Wiener, or Norman Wiener, if I'm not right. Yeah, I think so. Or in yeah. So there is no really notion of cybernetics, and there's no really real notion of how you can kind of define your kind of a relationship with the machine, so it's vastly rejected. There was this large kind of board on the wall that's posing a very simple question, and it's que pensez-vous de la recherche esthétique faite à l'aide d'ordinateur. So it's like, what do you think about an aesthetic research that has been performed and carried out with collaboration with the machine? And this was just like blank, and people started writing comments on it, and it's a huge shit show. Like, people are saying, you know, like, this is bullshit, and this is like it's programming error. This will never, you know, take off and whatever. So cynicism all around. And then we get to a point where you have works like this, which is an immersive experience and are kind of accepted, and obviously now in museums and, you know, permanent collections all over the place. This is a work called Messa di Voce, which is an interactive projection that's kind of like an immersive environment for two vocalists to perform, and as they perform, you kind of get this sensorial translation between voice and visuals and physics. So it's kind of like tapping into our understanding of the world based on laws of physics and things like that, and constantly makes references to what we know and what we have kind of used to create our fundamental understanding of the world around us, and creates an augmented experience for the artist, for the singer to kind of perform with. So I'm going to be playing this. I'm going to turn the sound off for a little bit, and perhaps making this a little bigger. So as this is moving forward, I'll be talking a little bit about that. Two of the main kind of collaborators on this project are Golan Levin and Zach Lieberman. I'm going to be, let me write those down right now. Hi.
Hi, Evan. How are you?
Welcome, welcome. If you are new, which you are, I would love for you to jump on this slide that I just pasted over here, and these are the notes that we are kind of going over. All right. So Zach Lieberman and Golan Levin, what was I talking about? Right. So something that's really interesting to start thinking about here is that as a digital artist, as someone who uses technology and computers to mediate an experience, that's something that you constantly have to be thinking about, because the computer itself has agency, and you as the author have a huge chunk of authorship in defining that agency. So in a way, whatever experience you're designing, you should be thinking in terms of a two-way back and forth feedback loop between man and the machine, and creating an experience that kind of involves that. So that becomes one of your that becomes your bread and butter. That designing and engineering the experience between man and machine, and that entire environment becomes the bread and butter of the digital artist. So moving forward, let me pause this thing. The videos are there if you want to look at it more. So that's all good and great, but couldn't we just like have digital art and just make programs that are interactive pieces and serve as a medium for the artist, and not have to worry about the internet? Like, why are we even talking about internet as platform? Why bother? So classic textbook example. This is Jodi.org's 1993 homepage that launched, and it kind of it's really interesting because obviously you just see gibberish when you open the page, and the overlaying kind of window that you see is the source code for that page. So it's interesting in a sense that it starts kind of exploring the medium web page as a medium, and it's a hidden invitation to kind of start in a sense understanding and forming an understanding of everything and anything that lives on the web as layered kind of systems. So when you land on the page, you don't see anything at all, But if you are kind of like curious enough to kind of read in between the lines and look at the source code, then you will see that that it's essentially a diagram for a hydrogen bomb. And in a sense, it's kind of like a hint on how internet as a platform and how web pages as medium will blow up in the next decade or so. Hence the hydrogen bomb. So that's like, that's whatever slideshow you see about net art. That'll definitely be there. So let's move forward to networks. So that's also another classic, kind of slide that you'll see in pretty much any presentation that has to do with internet or any kind of networking at all. So internet was created as a distributed network in a sense. Obviously the whole distributed network thing was supposed to be, and it's still supposed to be something that quote-unquote democratizes the flow of information and things like that. But we all know how that's problematic in so many different ways. But that doesn't mean that the artist can't really tap into this idea of art living as part of a network where other people not only can experience it but can kind of contribute to it in real time. And we will see how that works out when we talk more about networks and how we can use networks to create engaging experiences that live on the internet as their kind of as their universe. Another thing that's really important to start thinking about is that it looks like we have this kind of obsession with collecting data, and that goes far beyond the screen. So you get to phenomena such as Internet of Things, which is huge now, and you'll see like 5 different startups popping out like mushrooms here and there every day. And it's like, connect your dog's collar to, your phone, and it'll ring every time it goes out of your, a certain threshold, or, have like this smart thing in your house that automatically closes and opens your doors and shuts off and your lights and whatever based on the temperature. So you get to this idea that we are monitoring things very obsessively as human beings using the machines, and it looks like we are really kind of prone to using our machines and networks in that way. And as ridiculous or as super useful as this technology can be on the two other ends, to the ends of the spectrum, artists can come in and kind of like take on a critical kind of a stance and use that as the medium for work. So you have a network that you can tap into as a means for collaboration and real-time kind of input and output, which, as we said before, is the very foundation of what computers are and how they work. And at the same time, you have a huge, large, and growing pool of data that you also can use as your kind of as the kind of building blocks for your artwork. So in a little bit, we'll look at an example that is essentially using data to create a data-driven interactive sculpture. So these are the things that is important to think about when we think about technology, distributed networks such as internet, to create your work on top of that. And we also mentioned the importance of open source software and how we can use that to kind of build on top of. So I'm going to be playing a little bit of a video here. It's called Telepresent Water by David Bowen. This was also shown in iBeam when it was in Chelsea. I think it was summer of 2012 or 13. There are these stations out in the ocean, like outposts out in the ocean, that have been collecting and communicating data about water, about the intensity of waves, about sea level and things like that. This one particular station outpost kind of went floating away. So there is no deterministic way of figuring out where the station is right now as we were talking about it, but we're still getting live data from it. So this idea of telepresence and the idea that somewhere that we're not particularly sure where it is, something is creating, and transmitting data, is in and of itself kind of a poetic translation kind of process that can potentially be turned into something like this, which is you know. You can look at it as a telepresent kinetic sculpture. So this again is something that you know, something that you can think of the internet as that's the source for such inspirations and such kind of like atoms for creating your piece of art. But you know, something easier, like you could think about Twitter as a huge and growing like source of data. Think about if every time someone tweeted about like acceleration, you would like have something pop up somewhere on a screen that lives only on the web, and that could be kind of like a very simple, bare bones example of how you can use data as input for your work of art. Work of art. So let's talk about algorithm. I'm not sure if this thing is up. That's better. So Lewitt, proposal for wall drawing. So this predates obviously digital art, at least in the sense that we are dealing with today. But in a sense, it's process, and this is what I mean when I talk about artists kind of externalizing their process. When you are creating your work, you're completely you have a completely internalized process that you use to create an object or experience. When you start thinking about creating procedural algorithmic work, it is then that you have to start kind of externalizing your process and put it out there and kind of like work with it as another entity. That process in and of itself was obviously introduced as a work of art, but it was also carried out and actuated. It's kind of like energy that you can turn into kinetic energy, right? So it was a practice that that was really kind of enlightening, and this is exactly the kind of stuff that I would like you guys to start thinking about and kind of writing processes that you would like to see your work kind of being born out of. So then you take something like that, and then you hire someone or a group of people to actuate and actualize that kind of externalized process for the artist. And then you get to a point where you also can see things like procedural art that is not necessarily digital, but in a sense they share the same kind of spirit. So I'll be going over a few works by Tanish Weber, who's a Brooklyn-based artist and has created a series of photograms that are entirely procedural but not digital at all. So when you see works like this, you can describe essentially the algorithm for creating this piece in written language. For instance, you can say from the top left of the screen, which is entirely pitch black, take like 2 centimeters to the right and start drawing a line to the same point in the on the x-axis, but all the way down like 40 centimeters. And that instruction can be repeated a number of times, or you could choose to change that in a number of different ways to create results, right? So this is essentially heaven for computers, because computers are essentially super dumb. They don't know anything about kind of the assumptions that humans have, but at the same time they can be very efficient in performing a very well broken down series of steps that we define for them as artists and as authors. So there are works like this that are completely non-digital, but at the same time share the spirit of being procedural, and that's essentially why I'm bringing these examples over here. So a few years ago, someone came along and and was like, all right, if Soluit hired hands for performing and essentially actuating the work that he created the algorithm for, what if I came up with a series of computer programs that would translate instructions by Soluit into into an interactive, evolving digital art piece. So you can see that and before the kind of like the formation started evolving, you would see the instructions on the left side, and you would see the code on the right side. So if you look at the source code, it's actually fairly simple, but because of the nature of generative artwork, because of the nature of when you create a very basic set of rules and you let it loose in a system that would make whatever that's possible to happen, then you would see emergent behavior happen, and you would see that algorithms can create kind of exponentially more intricate kind of worlds and environments. And so, and I believe in the syllabus I have referred to this entire process as creating worlds, and this is exactly what it is. And that's essentially why I brought up the kind of the biblical reference. It's like you set out rules, you create a world, and you let it loose, and you use language to do so. And in this case, programming is language. So another piece of work that I'm really interested in sharing with you is a work by John Whitney. John Whitney created procedural algorithmic animations using analog computers. So working with these are super difficult. It's even beyond my really expertise and understanding. But this is still completely analog, and you can see that the kind of work that is created can be deduced to simple patterns. You see footsteps of repeating behavior, and when you look at it long enough, you can deduce the very fundamental patterns that have given rise to a complex system like this. If, for instance, if you look at any kind of sequence of this closely, you can see that you would potentially be able to sit down with a piece of paper and a pen and write down what you would need as the very basic rules that you would then let loose and kind of allow to happen, and it would create this kind of generative piece of work for you. And this is a good segue for deducing algorithms. It's interesting because when sometimes I look at signs, like even simple signs like neon signs that are like, rotating or evolving shapes. It's like a burger and a cigar that's like rotating and scrolling on the screen, or something like that. I try to deduce that into very basic, simple procedural steps that you could then take to create that image, and that's a really good exercise if you want to create procedural art. Whatever you see that you kind of can deduce it to small patterns, it's a good exercise to start thinking about it. It's a mindset. So the more you start thinking about it in that mindset, the better, the more fluent you become in kind of externalizing your process in a way that can be carried out as a series of instructions by machine and otherwise. And that's essentially the kind of the aim of the class today. So let's move forward. Let's get to pseudocode. You can also open it in your browser and look at it. If you have the slides, I'm also going to paste things over here. The link. All right. So we talked about procedural art and breaking things into actionable steps. Turns out that this has been actually very standard procedure in creating software, and that's before you get to the intricacies of how to describe your program in specific syntax of programming languages becomes the bare bones instructions. So programmers, before even diving in and writing the code that can be executed and compiled by the machine, they usually go through the practice of writing something which is referred to as pseudocode. So, for instance, number 2, this is a very simple kind of grading program, apparently, and the instructions are as follows. Set total to 0. So imagine if you have kind of a container, an entity that holds a number which is total. Set counter to 1. Now imagine if you have you know, a number of students or a number of papers to be graded. You set the counter to 1 because you want to go over and you want to grade each one of the papers. While grade counter is less than or equal to 10, input the next grade, add the grade into the total. So you can see here that you are essentially describing an evolving loop, right? When you see the keyword while, and then you see the sentence right after, the clause right after it, grade counter is less than or equal to 10. You can see that this is a very deterministic process. And this is something that we'll be hearing more and more about, deterministic. And that means that based on very basic, simple rules that you know, you should be able to determine with a very high level of confidence the outcome. And that's essentially what computers are really, really strong at, and that's essentially what we use computers for. So when you see something like while, keep that in mind, because this is one of the very basic constructs that we will see kind of implemented in different code syntax and different programming languages, and we'll be using this to write programs that loop through certain conditions and take certain actions for us. So you have a while, and then the clause right after that is a condition. So when you say while certain thing is true, it's like checking every single round that you're going in the loop. You're saying, is this condition still true? If it's true, I'm going to go ahead and perform the next 2 actions. Input the next grade, add the grade to the total. So let's say you have you know, like a grade of 85, and then you have a grade of 70. So input the next grade and add the grade to the total. So it's kind of adding that grade to the total container that we created on line number 1. And then set class average to the total divided by 10 while when that process is done performing. And then print the class average. So you can see that even before you have code, you can kind of, being experienced users of digital technology, you can kind of close your eyes and imagine what the program would look like. And that's exactly the premise of this class and the premise of this specific session that we were discussing. That's essentially why we're discussing this. So I'm hoping that the similarity between the pseudocode and the Solowit piece, which we saw a little bit earlier, are kind of apparent now. There's no really kind of, there's not a distinction between a program that you use to, I don't know, like manage a class, and at the same time a program that can produce a generative piece of art in as far as the technicality, you know, as far as technique is concerned. So let's move forward to the next slide when we get to emergence and randomness. So I'm going to read out loud a code from Rafael Lozano. Most electronic artists are looking for an out-of-control quality that will result in their work actually having outcomes that they did not anticipate. If the piece does not surprise the author in some way, then it is not truly successful, in my opinion. And this is where the algorithm for creating a program that takes care of, you know, grading a bunch of papers is different from a generative piece of work by an artist. Now, the artist might choose to create a highly deterministic process for the work, in a sense that every single time that you run the program that you wrote as an artist, it will yield the same exact result over and over again. If that is the concept, and if that's the take that the artist has on the medium as which is programming, that's fine. But as an artist, you're not then constrained by things like business requirements or things like that that other programmers are constrained with. So you can get kind of more playful with this, and that the nature of experimenting and getting playful with the code and your set of instructions is exactly the thing that creates that moment of delight where you create your program and you run it for the first time and you run it for the second time till the nth time, and you see how things evolve and how things happen and how your algorithm on a low level can give rise to a higher level, more complex, evolving kind of phenomena. And this is what I take away from this code, and we will see a little bit later how we can use our programming language to serve that purpose for us. You can write something that runs the same every time, or you can use different techniques and leverages that we have to create something that's not deterministic, but obviously on purpose. Moving forward, so Charles Surrey, and quite frankly, I've never actually heard anyone pronounce this name, so I'm just going to go ahead and assume it's Surrey with a silent C in the beginning, and forgive me if I'm wrong on that. This is a 1967 piece that's called Random War, and you can see that the very basic repeating pattern in the work is that kind of like the toy soldier. And you can see that there's a specific algorithm in play that repeats the soldier, but in a way that's not deterministic. So the idea being that that kind of like this, the kind of critical take on war and how it's like sparing really no one, and how the kind of like the banality of evil. It's like pointing at every and all directions every time. How that is essentially created by an algorithm that is not deterministic at all. Like, I'm sure if you have the source code for this software and if you run it again, it will yield a different result every time. And that's kind of what we want to get comfortable with and experiment with. And this is another piece called Sine Wave Man, which is, as you can see, kind of using sine waves as the very basic algorithm for drawing. So you create a portrait, and then you run it through an algorithm that takes every piece of line and determines where to cut it off and turns that into a line that's comprised of sine waves of different angles. So this is kind of, again, along the lines of what I was talking to you before, which is when you look at a work that's generative, it's a really rewarding experience to sit down and kind of try to deduce it to its patterns. And we get to nature, which is kind of abundant with low-level phenomena that give rise, low-level kind of rules that give rise to very complex phenomena. Swarms and flocking are yet another kind of example of that. If you think about it, if you're a bird, all you think about really is, I want to stay with my group, and at the same time, I want to be, say, one wing away from my right and one wing away from my left from the two bird friends of mine that are flying on two sides of me, and like 5 beaks away from the dude like flying right in front of me, and the same with the bird right behind me. You don't really think about, or you don't really have any holistic way of looking at what this simple algorithm on a molecular level gives rise to. But when you look at it from the outside, you can see that a low-level kind of behavior gives rise to a very complex, high-level emergence system. And this has essentially been one of the earliest and most crucial reasons where computers were kind of created and kind of pushed towards getting better and better technically, because obviously people needed simulations for things. If you want to, put a satellite on Earth's orbit, you would want to simulate every single possibility and every single physical kind of force that comes into play when you're launching your spacecraft. So you would kind of start optimizing your machines for the ability to create and simulate the world around us. And simulation is also something that we'll be looking at later on in this course. And we will see that we can create very simple instructions and create a lot of different objects that inherently follow that very simple set of rules, and then we can create more kind of intricate and kind of more kind of complex systems. So looking at flocking, let me close these two nags. This is essentially the same kind of flocking algorithm, which is created using programming. And you can see that the dumb machines that we talked about are really, really good. They're like extremely, on a very low level, very obedient and very dumb. And you can essentially just feed them instructions and let them loose and see high-level phenomena emerge. Do a barrel roll. Okay. Pause. Let's move forward. Whoops. So let me just move forward and does anyone have any questions? How's the pace? How are things? Any feedback?
I have a question, though I'm not really sure how to ask it.
Please.
I guess I'm thinking about maybe the video that you just showed of the simulation of the flocking, and trying to imagine then what then would be the directions or the like the determinations that would create something that would be emergent. And is it? I guess my question is: it always spatial? Is it always sort of based on coordinates within a frame, or if there are other directions?
I see. Okay. Right. So there are a lot of different ways that you can start thinking about it. So think about it this way. Think about an inherent behavior that every single bird in that flock has. And if that inherent behavior is to move in a certain direction because of a very basic kind of natural need, like we're moving from point A to point B, then you inherently have a direction, right? But at the same time, everybody else around you have that kind of direction. But there are always deviations. Like if I'm a bird and baked into my flying behavior, I always have a deviation of like 2 angles to the left and to the right. Then think about this as a domino effect. So everybody, like every single bird around me within a certain radius, would have to adjust themselves to my deviation. And so that would create this kind of domino effect that when you look at it from outside, you will see that something that would be a movement towards a very general direction with a very small deviation can create large, complex kind of movements in the space. So kind of get used to thinking about animations and algorithmic kind of generative animations, not necessarily, and I mention this because you brought this word up in your question, which I believe was really good to point it out, frames, right? So you can think about things in frames in like in an animation that you're creating, with onion skinning and like kind of more sort of traditional animation techniques, right? You go frame by frame, but this is a fundamental shift in thinking about animations, and that's you have a large number of objects that have similar behaviors out of the box. Like, you have an object that's called a bird, and this bird knows how to fly, and this bird knows what direction to go to, and this bird, baked into it, has a specific tendency to turn a little bit left or to the right, right? And let's multiply this by 1,000, and let's let this loose into a world that has gravity, a world that has wind, and all these different kind of inputs that come into play and change the algorithm. And you will see how things emerge. So in a sense, you are moving from an art. As an artist, you're kind of, I don't want to say graduating, but I will say it. You know, feel free to object. But you're graduating from creating frames. You're graduating from creating objects, and you're graduating from creating end products to creating processes that create the end product, right? So does that answer your question in a sense?
I think so. I mean, I think maybe the method then feels still a little bit abstract, but I think we'll get there.
Yeah. It's just a different kind of it's a different kind of way of thinking about things.
Mm-hmm.
But yeah. So this is. Anybody else has any questions? All right. So let's talk about Conway's game of life. Mathematician creates a very simple world within which you have very simple rules. And these rules are, 1, any live cell with fewer than 2 live neighbors dies, as if caused by underpopulation. Number 2, any live cell with 2 or 3 live neighbors lives on to the next generation. Number 3 is any live cell with more than 3 live neighbors dies as if by overcrowding. And number 4, any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. So you can see that when you talk about as if by, as if this, as if that, these are conditions that we are kind of like assigning to you know, like overpopulation, you know, it's like overcrowded, it's reproduction, and all these different things. And you can see that when you create objects that inherently are born with this behavior, and you create kind of like multiplications of all of these, and you put it in a world that then allows them to actuate, they will kind of create this evolving emergent behavior. And so this is also, you know, when you see something like this, you should also start thinking about epidemiology and how, let's say, you can start simulating you know, an outbreak in a specific area, and you can say, all right, let's imagine if one person comes into contact with two other people, and so on and so forth, and let's say that the lifespan for each patient from the time that they contract the disease is, let's say, like 5 months. And within this 5 months, they can kind of, you know, essentially pass their disease along to other people within a specific radius. So you can see that we're making assumptions, and these assumptions give rise to certain rules and regulations that we can then use to start simulating things. And in a lot of ways, you can see how that's similar to the game of life, how that's similar to the animations that we saw from John Whitney earlier, how it's similar to Sol LeWitt's work, and how it's similar to pseudocode and things like that. So let's move forward. Let's talk a little bit about I/O. While emergence and, you know, kind of thinking algorithmically is important, you should also start exploring, again, computers as input-output machines that receive input from you and at the same time feed something back to you as the viewer of the piece, and so on and so forth. So think about this when you're thinking about creating work of art, digital work, interactive work of art, think about a dialogue between you and the machine, and think about how you want to start creating that dialogue. So this is a piece by Daniel Rosen that was exhibited in Bitform's gallery, I believe ended in July 1st, and it was like on since May. And this guy is actually pretty big on creating these interactive sculptures, and it is the kind of like fine-tuned artistic details of the sculpture itself, like you see here at Pom Pom Mirror. The actualization of all these different little fluffy balls using very small motors that kind of imitate the behavior of the person who's kind of interacting with the piece. All these different things are essentially kind of your kind of different leverages as an artist to start experimenting with these things. But when you really boil it down, you will see that you're giving an input to the machine, and the machine is doing something for you. So the machine has a behavior on its own, just like you see how it's like expanding that little circle from the middle. And at the same, so it has its own kind of authorship and agency, and at the same time takes input from you and reacts to that. So I want you to think about, again, machines as procedural actualization kind of automaton, and at the same time think about it as an entity that you can create a dialogue with. At the risk of being too self-absorbed, I'm going to show a little piece here that I made for Dumbo Arts Festival last year, which is essentially a framed LCD with a camera. So the camera looks at you and picks up your face, and based on where you are and how you're moving around and interacting with it, starts kind of talking out loud. It's more or less like a soliloquy than a dialogue. So it's kind of it was kind of my take on how, you know, perceiving a work of art is not really a one-way street, and how a work of art that's stored away in a basement in a museum is by no means the same work when you put it in front of 100 people or 1,000 people. So it's kind of like a changing experience as you move the work of art in different places. And so the statement was the work of art doesn't really exist until you perceive it, and so that's why the screen would be completely white unless you would start interacting with it. And based on your distance, based on the kind of input that you give to the machine, different behavior would emerge, and you would kind of like be able to tap into the mind of the machine, which was a very, very simple simulation of you know, a personified kind of machine. So the importance of this is obviously not because I made it, but it's important because this thing is essentially running in a browser. What you see from a technical standpoint, and I will be going back and forth between you know, concept and techniques, because we're going to have a hands-on class. From a technical standpoint, that white background that turns into this interactive screen is essentially a full-screen Google Chrome browser, and all the code is running inside of the browser, and that camera is kind of processing that information in real time. What this makes possible is, imagine if you can have like 10 of these installed in different places, because essentially and inherently the code runs on internet as the platform. You can see how you can create real-time interactions between different nodes of a distributed network, which is the internet. So it provides a lot of different possibilities for you when you start working with programming in the browser and on the web. So we have a little bit more about an hour, and I would like to start actually talking about the nuts and bolts of programming and move forward. If you guys have any questions or any comments, please feel free to go ahead now. Okay, cool. Either everyone's on board or super bored. All right, sweet. Thanks for the feedback. So let's think about programming concepts. We live in a continuous world, not as far as quantum physics is concerned, but as far as we can see, things are waves, things are continuums. Computers are not like that. Computers are really strange philosophical creatures that are constantly resonating between a complete non-existence and existence. We refer to all that from as zeros and ones. So there's no such thing between and such as an in-between kind of space in a machine. A machine thinks about it's either kind of like an atom is either there or not there, and based on that, depending on how many atoms you have, you will get a more or less high or lower fidelity simulation of the phenomena that we're used to in our in our physical world. When you think about it, our faulty vision is kind of the only reason that we can see continuous images on our computer screens, because computer screens have a refresh rate, and every single pixel is either on or off. And these pixels are constantly updating, but they give us the illusion of a continuum. So this fundamental understanding of bits, which is essentially the most fundamental atom in computer programs, which is either 0 or 1, either there or not there, right? Multiply that by millions and put that side by side with the power of our massive processors and RAMs that have been exponentially growing by Moore's law, create this kind of illusion of continuum experience as far as sound goes, as far as imagery goes, as far as anything else goes in the computers. Even the sound that you hear, and we will be looking at that in a little bit, even the sound that you hear in computers, MP3s and audio CDs and things like that, are totally not sounds. We perceive them as sounds, or I stand corrected, are sounds, but are not the music that we listen to when someone plays on a string instrument or on a piano live in a room. There are simulations of that sound, and that simulation, along with any other simulation made possible by computers, are essentially made on the basis of zeros and ones. It's a constant fluctuation between being and not being, multiplied by millions. So let's move forward with that kind of mentality. Let's talk about low-level and high-level languages. Because machines work either from machines essentially speak the language of zeros and ones. So if you really want to, kneel down and bring yourself down to the level of the machine and whisper to the machine's ears without any sort of intermediary interpretation, you would have to whisper zeros and ones to the machine. But that's too much work, because we don't think like that, because humans need mediation. They need levels of abstraction to be able to talk to the machine. So what we do is we start creating higher level languages that are then, through a process, turned into the lower level machine language that the machine can understand and execute. So the same instructions that we talked about, circling back to Soloist and generative art and things like that, the way that we describe them in programming languages that we will see in a little bit in JavaScript, there are multiple layers between when we write our code that is human readable, which is why programmers can work, because otherwise they wouldn't be able to work, right? You imagine sitting down on a machine and typing in zeros and ones in the hopes that this will someday be, Google Hangout. It's even impossible to think about. So we create abstractions and we start using what's referred to as higher level computer languages that are then translated using the machine to lower level, so that it kind of like turns into binary, which is, again, zeros and ones and runs, right? There are two different schools of thought when we talk about translating a programming language from a high-level kind of human-readable computer programming language to a low-level zeros and ones. One is an interpreted language, And there's one school of thought is interpretation, and the other one is compilation. When you click on an application on your desktop, regardless of your operating system, an executable file opens, right? So you open up your browser, right? What is that? What is that browser actually represent? What is that program actually represent? That program is a compiled version of thousands of lines of code that a team has developed or someone has developed. But they go through this intermediary process of, all right, this is my code. I'm going to use this another computer program, which is called compiler, and I'm going to compile that into an executable format that then you can click on, and it'll open up as a quote-unquote native program, right? So that's that. That's one school of thought. I'm going to write a program, and that program is going to be compiled into an executable binary format, and then my machine can understand and run. Or I'm going to be interpreting this live. In other words, I'm going to be writing code, and I'm going to have a smarter compiler that is capable of only turning those instructions that I want executed right now into machine code and run it immediately. Again, another great reason why learning JavaScript for creative coding can be rewarding, because you don't have the compilation steps. You write your program, you refresh your browser, and there it is. You don't need to compile, you don't need to do anything like that. And I'm mentioning this because in a little bit we'll look at two other kind of ancestors of the JavaScript subset that we're going to be using, and all of those need compilation because they are designed on top of languages that require compilation. So when I talked about simulation and sampling of the real world, let's think about a sine wave, and let's think about how the sine wave on an oscilloscope looks like. It looks like a complete continuous wave. But in order for the machine to understand this, it has to break this down into several steps. Now let's look at B. I'm not sure if you see this is better. Okay, this is better. Let's look at B. You see how you are kind of sampling the wave here? This is what I mean by sampling, meaning that the machine says, all right, here's what I'm going to do. In order for me to understand the wave, in order for me to represent the wave, I am going to say every 10 degrees, if you think about sine and cosines as functions of degrees, every 10 degrees I'm going to be calculating the sine wave right here and right now. The sine value right here and right now. I'm going to move forward another 10 degrees and calculate the sine right here and right now. Move forward, so on and so forth, until I get to a full I believe that I think this is 2 pi, if I'm not mistaken. My math is a little rusty, but we'll get to sines and cosines actually when we start writing simulations and things like that. So you can see that the machine understands a continuous wave only as good as its understanding of separate digital instances of that wave. So if that 10 degrees turns into 20 degrees, we will have a lower fidelity wave. But if that 10 degrees turns into 1 degree, you'll have a higher definition because you're sampling your wave at every single angle. So you'll get a more continuous kind of wave. Whereas, for instance, in number C, you see that this looks jagged and looks pixelated, and it will sound crappier also. This is why when you listen to MP3 and it's like lower bit rates, you can see like the sound is not really good, and then you increase the bit rate, and that's essentially increasing the sampling rate. When you increase the sampling rate, you will have a higher fidelity presentation of a continuum as opposed to a crappier sound. So this is also important because I want you to start thinking about how computers think. In order for the artist to move closer to the computer and appropriate a computer to be the hired hand that she needs to execute a work, or as a partner to create the work of art with it, you would have to at least understand the very basics of how the computer thinks about things so that you can speak its language a little better and more efficiently. So this is why these examples are important, not necessarily because we want to be creating like MP3s out of, you know, whatever, like audio recordings or anything like that. But it's important. So I'm gonna take a bite out of this thing. All right. So let's think about let's talk about coding. What coding really is nothing more than encoding a thought process in a specific language, which at the other end it's decoded by the machine. So it's really understanding a contract between you and the machine that you both have the same understanding of, and you can kind of talk the same language. When we saw Manfred Mohr's work, which was the evolving cubes, the mustache dude with the huge plotter, like super retro looking, that guy was writing a program called, in a programming language called Fortran. Fortran is a very low-level language, and it's still used in some banking systems because they started developing their programs back in the 70s. And it was a robust enough computer programming language and secure enough language that they still, to this day, a lot of banks still use it. But we've come a very kind of long way from those earlier days where things are more closer to the machine language and farther from the human language. Then artists kind of started creating their own tools. Artists started kind of developing higher kind of, you know, understandings and knowledge of programming, and they started developing their own tools. Two of the more famous ones are processing and open frameworks. I want to circle back to abstractions, and I want you to start thinking about abstractions and what it means again. You low-level phenomena to high-level phenomena, low-level computer programming languages to high-level programming languages, go through different levels of abstraction. Let's think about you know, furnishing a house. On a very low level, you would have to deal with things like assemble all the IKEA crap that you bought, and every single one of those is going to be a bunch of instructions, very low level. And then you're going to have to think about, you know, carpeting. And carpeting is broken down into a lot of different instructions. You would have to think about moving things around. You would have to think about lighting and all these different things. Let's make that one level more abstract. You can say like assemble furniture, move furniture around in the order that you like, carpet the house, fix the lighting. Let's move this another layer of abstraction. You know, about fix fixtures. Take care of carpeting, make sure furniture is fine. Another layer of abstraction would be take care of, you know, like essentially perform the act of moving into a house. So you can see how you move from more granular low level to higher levels, right? And so what things like processing and open frameworks do is they provide higher level utilities, more abstract utilities for artists to be able to approach programming easier, so that they don't have to worry about the nitty-gritty and the nuts and bolts of, you know, like the IKEA guide for putting together something. They don't have to worry about that. Creators of these libraries and these frameworks, and in a minute I will describe the difference between a library and a framework, thought that, all right, so you know what, we're writing this code to create our art, and we were seeing that this thing is growing naturally, so we're going to open source this, and we're going to invite other artists to kind of adopt this and experiment with this and things like that. So instead of, let's say, having to go through hell to describe to the machine what drawing a rectangle on a screen actually involves, which might be, you know, involved in kind of translating your instructions into GPU instructions for your graphic card, and the graphic card has a specific programming language and a protocol, and like all that stuff is abstracted to one command, and that one command could be rect, short for rectangle, so that you can just pass like 4 values to a rect kind of instruction, which could be the x and y coordinates and the height and the width of the rectangle, and there you have it. You have a rectangle on your screen, and these are essentially possibilities today for artists because people have been creating libraries that abstract the kind of more difficult and more unnecessary things to deal with for creative coders, so that you can easily pick those tools up and start moving forward. I have links here for processing, open frameworks, and P5.js, which is what we will be using. It's cool. It's these are pioneers in actually in creating digital interactive code work. Processing is built on top of Java, which is a very robust general-purpose programming language. So in a way, it's an abstraction on top of Java that uses the power of that programming language, but at the same time makes things much easier and the barrier of entry and the learning curve much smoother for people who are approaching this from a creative standpoint. Open frameworks is another kind of set of tools that you can use, which is built on top of C++, which you'll be hearing these words, and I'm gonna just be throwing these jargons out there because you know, inherently this entire class will be, you know, more or less techier, so it's useful to kind of, you know, hear these things and get used to them and kind of add it to our vocabulary. Open Frameworks is written on top of C++. In a sense, it's creating abstractions on using that language. But then, as browsers became more and more potent in executing code and in running more and more complex instructions, people started seeing a trend in moving away from compiled languages, if you remember before, such as processing and open frameworks, towards a more real-time, easier to execute, and lower kind of overhead languages, such as JavaScript, which runs instantly in your browser. So some folks at NYU's ITP program, Interactive Telecommunications Program, essentially started translating everything that processing would make possible for you, but using JavaScript so that you can write the exact same things that would run seamlessly and smoothly in the browser. So we're going to be using P5.js as the library for this class. The link is there. And if you open it, you will probably see some sort of goofy, evolving, you know, lines across your screen, and it's kind of like showing off what we can do. If you hover over the P5.js, oh, look at that! If you click, you get more waves. That's fun. It's the first time seeing that. Yeah, so all that stuff is running in the browser. Like, you don't need any other overhead. So that's why we're going to go with JavaScript. We're going to be learning P5.js, and we're going to be moving forward with this. I would like you guys to explore P5.js, look at the examples, look at the references and things like that, and get comfortable with looking at documentation, so code documentation and what it means. If you're a programmer and if you write a library, and a library, again, another piece of jargon, a library is a set of pre-written code that someone or a team or whoever has developed that you can plug into your program that makes it easier for you to take care of a specific thing. Let's say I want to create an audiovisual experience that involves playing sounds, that involves sensing motion from the audience, and involves projecting a large image on a gallery wall, right? I would either have to figure out everything from ground up, like figure out how to deal with sound waves, how to deal with signals, how to process camera input, and how to process the kind of the projected image that I'm going to include in my work. Which would be a very daunting task and would be extremely counterproductive. So there are libraries, there are pre-written set of tools that you can plug in and use those as Lego blocks, so to speak, to make it easier and facilitate the process of creating an artwork, or creating an experience, or developing and prototyping an experience. So that's essentially what P5JS is. That's what it does. It allows you to move from having nothing to having a working interactive or digital generative piece in much shorter amount of time, because it takes care of a lot of the low-level implementation details of your program. And every library that is kind of unleashed in the wild comes with a reference. And it is crucial for us to get used to reading references. It's kind of like a dictionary. And as programmers, you would want to get comfortable with looking things up in whatever library that you're using in your code, to kind of get a sense of how you can use different things. So we haven't talked about code at all, but I just want to show you that what a what a reference potentially looks like. So let's look at a rectangle. Drawing a rectangle at location 30, 25 with a width of 55 and a height of 55, right? So before I even talk about what this code does and what it means, which should be pretty self-evident, with one line of code you can create a rectangle, and you just take it from here. You are looking at a reference, and the reference is telling you how to draw a rectangle. So if you are writing something, if you're experimenting with your code and you get stuck, you'd simply look up the reference and be like, oh, it would be great if I could have like a Bezier curve that I could have have it rotate or whatever. And then you could look up all these things. And the more you get into the mindset of how to put these pieces together, the easier it becomes for you to quickly get from having nothing to have something working. And that takes time, and I do realize that 4 sessions is not enough to cover a lot of these things, but what I'm hoping is that building very gradually and slowly, but at the same time profoundly, we can create a platform to propel us into a space where we can autonomously explore different kind of possibilities in writing code. One piece of an important piece of information to keep in mind when you are drawing things on a computer screen is that the Cartesian plane that we are used to and we are taught at school start from a 0, 0 of the bottom left, and then you move up and move right, and as you move up on your y-axis, the values will increase, and as you move right on your x-axis, the values also increase. You have to get used to imagining all of that upside down in a drawing environment that is programmatic, because when you think about the 0, 0 point in a computer screen, think about the top left corner. That would be your 0, 0 code. So with that in mind, let's circle back to this command that says rect 30, 20, 55, 55, right? So it's asking the P5 library to draw a rectangle on the screen 30 pixels on the x-axis, and as you can see, because the 0, 0 point is on the left, top left part, it makes sense that it's 30 pixels to the right, because you start increasing on the x-axis from left to right, and then 20 pixels from top to bottom, right? So you can see how the Cartesian plane is now reversed, because 0 is at the top and 20 is 20 pixels below, not above, below the 0 point. And 55 and 55 are the width and the height, right? So what is rect? Rect is a function. And we'll get to functions in a little bit with my goofy GIFs and whatnot. Maybe, I don't know if is it a GIF or is it a GIF? I'm in eternal struggle between these two. Let's call it GIF for now. We'll get to what functions are and what they do, but just take it as face value. Rect is a function that draws a rectangle, and it expects you to give it x and y coordinates and height and width, and that's pretty much all you need to know in order for you to start working with a function that draws a rectangle, right? And in the second example, you see that the rectangle takes the x value, the y value, the width and the height, and it can also take another value, which is the border radius. It can smoothen the border for you. So you can pass 20 to it, and it will smooth out the radius, right? Now, you might ask, how am I even supposed to know that I could throw in a fifth number in there and it will smoothen out, the radius around it? Well, that's exactly why this part of the website is called reference. Let's look at the syntax. Syntax is exactly the same, used in the exact same meaning as natural languages. You have syntax, you have verbs, you have nouns, you have adjectives, and these are all the atomic building blocks that you use to describe your process in your world. So syntax here is kind of described as a kind of a sample use case, and you can see that you have a name, and then you have parentheses, and inside of the parentheses you have different comma-separated values, and these comma-separated values are parameters, and we'll get to parameters in the goofy GIFs that I mentioned before in a little bit. But you can see that you can draw a direct parallel between the simple syntax and the use case that we see up above. So the syntax says it takes an x, y, w, and h for width and height. And so by looking at the reference, you can figure out, okay, so probably the first one is the x, the second one is the y, and as you experiment with that, and because we can experiment with it really well and immediately, because we have the advantage of writing the code that runs in the browser, which we'll get to in just a little bit, you can in real time move your rectangle around and get a feel for what actually this function does. So you can experiment with this. Nothing blows up. We're not writing a program that takes care of security for international bank transactions. So if our program blows up, whatever, we can just start from scratch, which is great. So there's no overhead. We don't have to throw away any material. We're not wasting ink. We're not wasting paper or anything like that. We can just delete our program and start all over again and experiment with it. Look at the documentation, at the reference, and figure out what piece of code does what. This was only a very small example of how to think about using references in libraries and programming languages. All right, so we talked about internet briefly, and I want to kind of move forward and move closer to the end where we actually start looking at code and concepts of code. But I remember, I think it was Olivia and Nushin who mentioned that they worked with HTML, and internet is essentially a lot of we like to call it the cloud, but it's not really the cloud. It's just huge warehouses that have a ton of servers, large computers that are connected with cables that are laid below the sea using some really strange techniques. And it's really a combination of all these machines that are connected with each other, and they all observe very specific protocols. And these protocols are in place so that you can have different machines and you can have different computer systems talk to each other and understand each other's language. For instance, if you load any web page at all, you are using an HTTP protocol. Your browser is talking to the server with an HTTP protocol, which stands for Hypertext Transfer Protocol. If you log into any website that requires you to use username and password, chances are that you're using an HTTPS protocol, which is a secure version of that. If you're uploading any file on the internet, if you know what you're doing, you'll be using FTP, which is File Transfer Protocol. So you see that computers in general have the tendency, I mean, humans have in general the tendency of designing intricate, complex systems in a way that they're broken down into a lot of small parts, yet they have a language to be able to understand each other and work together. And in this case, that's called the protocol. So I mention this because I would like you to think about internet as not this like weird, like, fairy tale thing which makes things happen and draws things on the screen and transmits images and audio and video and stuff like that. It's all just a set of computers that are talking to each other through a protocol. On the earlier days of computing, when two computers would actually start talking to each other, they would have a digital quote-unquote handshake. And it's interesting that we kind of that we think about that as a handshake. That means if you remember the old dial-up modems, the weird sound that you would hear where when your computer would connect to the internet, that was actually a digital handshake between your computer and a server that would serve you files, right? And that again, it's another protocol. So we have computers, small entities that are able to talk to each other through protocols. HTML is the native descriptive language of the web. It essentially describes the structure of your page. We will not be dealing with HTML in depth because we want to focus on JavaScript. But think about HTML as a language to describe different elements on different applications and different elements on your page. If I were to describe a room, I would draw a box that inside of which there is a door and a window, and inside of a window there is a latch, and there's also a piece of glass. So you see what I'm doing there? I'm describing a page. When you look at Google's homepage, there is an HTML file there that describes the page in a sense that it says, all right, draw me a page. In this page, I'm going to have a bunch of links, and in each link, I'm going to have a title, and I'm going to have a tooltip. When you roll over it, the tooltip will roll up. So, and then you have that image and whatever. So it's all about description. In that sense, it's not really a programming language, but it's a descriptive. It's a descriptive language, and it stands for hypertext markup language. It's marking up in the same way that you go to a supermarket and everything is labeled and marked up. That's how browsers understand what we mean when we talk to it and we say, create a page and put all these different elements on it. That's as far as we're going to talk about HTML. You will very rarely hear about HTML throughout our class from now on, because we want to focus on JavaScript. But it is crucial to know that HTML imports your JavaScript file. So you write a JavaScript file, your HTML, you link it to your HTML file, and your HTML knows how to run it internally in your browser. So that's as far as HTML as you need to know. If this was a web design or web development class, then we would have to talk about this thing in much more depth. But we're essentially just using HTML as a stepping stone to get us to a canvas that lives on the browser that we can use to draw things on and create engaging, cool experiences and procedural artwork with. So So that's that. And then we talked about interfaces. When you say interface, the first thing that comes in your mind is, you know, your phone screen that you can interact with in a specific way, either through pressing keys or swiping or other user interfaces. But that's not what all interfaces are. Circling back to the idea that computers are distributed smaller entities that all talk to each other using their own weird digital handshakes and protocols such as HTTP and FTP and stuff like that. Those are also interfaces. Those are two computers interfacing in a specific way, right? It's interesting to think about those things in that way. And then you have a notion of APIs, which is application programming interface. So let's say you have an iPhone and you want to write an application for it, right? iPhone inherently provides an interface for the programmer to be able to program for it in the same manner that JavaScript is exposing a specific interface to our browser that we can program for it. So when you think about it this way, you will see that we are dealing with interfaces on much larger and much more profound and fundamental ways that we even think about on a daily basis, and that's essentially a understood, agreed upon protocol that we can use, and we can talk to the machine and write programs for the machine. It is not crucial for you, however, to remember all of the stuff that I said. That's why I have just included these as bullet points. There is a little bit more detail on the roll-up of the notes that I put together for this sessions class, and feel free to look this stuff up. But this is all just providing a framework, understanding the landscape of the internet and the networked objects, so that we can contextualize our knowledge of programming, our knowledge of JavaScript on top of. So let's talk about programming concepts. This is the fun part. Any questions so far?
I have a quick question.
Please.
I was just looking at the reference that for the P5.js to JavaScript, and then the reference that you were showing for Rect and how like you can draw a rectangle, and I couldn't help notice how similar it is to processing, where actually it's exactly the same. I was wondering if you could tell me a little bit what is the difference between Java and JavaScript language, and why their name is so similar. But I remember you told before that they're very different languages.
Yeah, sure. Yeah, absolutely. That's a good question. So if you, so circling back to processing, another tool that you can use for creative coding, it is exactly, essentially a very kind of more or less one-to-one port. In other words, rewriting the same functionality with the same look and feel of that library, which is processing, but in JavaScript language. It is a coincidence that JavaScript and Java have the same name. It was merely a very kind of like, it was a marketing stunt back in the early 90s. Java is a language that is a compiled language, meaning that you write the code, it compiles it to an executable file that you can click on and open it natively in your browser. JavaScript, however, in the dawn of the browser wars, if you're, you know, like old school enough to remember, which I think all of us are at this point, there was a point where Netscape and Internet Explorer were, you know, on a battle to rule the world of the internet, and they were creating they were releasing browsers, and there was no really unified way to implement different technologies in these two. It was a hegemony of browser makers, and it still kind of is, but at least now it's more democratized because there are open source bodies of contributors, of people actually working in technology that define the specifications that are then implemented by different browser makers, such as, you know, like Safari or Chrome or Firefox, and they're all in concert with each other in a sense that they talk to each other and they come up with standard specifications and they implement their specifications. So you have a unified way of writing JavaScript that runs equally the same on Safari and then Mozilla Firefox and then Chrome and Internet Explorer and whatnot. Going back in the early ages of the internet and personal computing and AOL and those weird CDs that came with AOL that you could put in and hook you up with the dial-up and whatever. In those days, Netscape was like, all right, we need to roll out a language that allows us to click on buttons and different things pop up and like have really weird, quirky, kitsch like interactivity in our web pages. And they put together this really hastily put together language with a lot of flaws. And because at that time I believe that Netscape owned the right to Java programming language, and Java was really popular back then. It still is, but it was rising in popularity. They wanted to piggyback off of that marketing, and they called this language JavaScript. But it has nothing to do. These languages are very different. The underpinnings and how they actually work under the hood are really different. So that's essentially how these two are still commonly mistook for each other. They really don't have anything to do with each other. But JavaScript evolved and it matured in a way that it makes us possible today to sit together from the UK and different parts of from the US or wherever else and collaborate with each other inside a browser window. This shows how far JavaScript has come as a language. A lot of the flaws has been solved. A lot of new, very powerful features are constantly being added to the language and making an excellent choice for engineering and at the same time for artistic production. So seeing all of that, in light of all of this, and in light of JavaScript becoming one of the most popular programming languages, and in a sense the lingua franca of the web, creative programmers decided that they needed to translate tools that live outside of the internet, that are not native to the internet, and they need to translate those and bring them over to the language that is spoken by any and all entities on the web. And that's why they made this transition. Processing still lives on as its own thing. It has its own community. It has its own it has its own use case, and it's very powerful. But P5.js is essentially the exact translation of the same things. But the advent of this is that the advantage is that you can use all of this in the browser and it runs natively. So that was a little too much of a rant, but these answers usually need a little bit of building up to get to. Does that answer your question?
Yes, thank you so much.
All right. No worries. Okay, moving forward. All right, so let's talk about programming. The very basic atom that you need in a programming language, in any program, is a variable. A variable is a box that you use to store something inside of that you will be using at some point later on in your program. So think about variables as reusable boxes that you store things inside of, and then you can use these boxes and you can use the values that you've stored inside of these boxes to do all sorts of different things. And we'll get to examples just in a tiny bit. I have some examples listed here. All right, I have some examples listed here. So I'm going to be drawing parallels between my goofy GIFs and the actual implementation of these concepts in JavaScript so that you can see the relationship between the two. Again, I do not expect you to start writing JavaScript, but it's not hard at all, but it's it takes a little bit of time to internalize these things. So that's why I want you to kind of try to grasp these concepts and not necessarily entities that are implemented using the programming language, but just see them as high-level concepts and try to internalize them as such. and then we will make a transition slowly between the concepts and the syntax that then would turn into the programming. Would turn into the program. So we will be going constantly back and forth between high-level concepts and the actual reflection of those in the computer language syntax. So I have a box, and inside of that box I store some value. I want to write a program that takes, for instance, that stores the number of plants that I have in my house, because later on in my program I'm going to be using this for something. I create a variable, I call it number of plants, and I store number 20 in that variable. So, and for the lifetime of my program, anytime I refer to plant number, it will always give me 20, unless I change it at some place in my program else. So again, it's a box that you can use to put something inside of. Let's talk a little bit more about different types of variables. First type of variable that we're going to deal with is a string. Now, as weird as that might sound if you're not familiar with programming, a string is nothing but a bunch of letters put together as one entity. So let's say a banana or an orange, any written word, 3 passages of a Shakespeare piece, anything like that that's only built out of letters is called a string. And the computer understands a string if you simply denote it using, let me go ahead and open up my code pen so maybe I can very quickly show you what I mean as I move forward. Does this thing have? Let me use. For now, I'm going to be using something called JSBin, which is very similar to CodePen, but it has a console output. Let's open up JavaScript. We don't need this. Let's write a variable here. This variable is called artist name, and it's equal to Frida Kahlo. Right. This variable is a string because it's comprised only of letters put together. And can you see my screen, or I can't see my own screen in the. Can you see what I'm typing? Okay. Okay. Good. Awesome. So in the same way that you're creating this box called name and you're putting the value Frida Kahlo inside of it, just for the sake of parity, I'm just going to turn this to name, right? You can see that in the same manner you're creating a container and you're putting some content inside of your container. I'm going to be using a command called console.log, which is something that we're using frequently. What it does is essentially it outputs whatever you ask it to a console. I'm going to open up a console. And console is essentially machine's output, in a sense that you can ask it to tell you different things, you can ask it to print different things into the console, and you can look at the console to extract certain information about your program. If there are vague parts about this, I'm going to make sure that I'll be including all the examples and little snippets of code that I'm including in the class so that you can go over this and look at it on your own time. And I'll be posting this right after class, either today or tomorrow. But let's take this as at face value and say, I have this magical command called console.log, and I can pass any variable name that I have formerly created inside of my program, and it will print it out for me. So I created a box, called it name, and then assigned the value Frida Kahlo to it. It is a string. It's important to know that computers understand strings or written letters only if you denote them using single or double quotations. So this is what really constitutes a string. You can use either. You can use either double quote or single quote. And in the same way that a full period, full stop in a natural language denotes the ending of a sentence, semicolon does the same thing for us in a programming language. So in some programming languages, including JavaScript, it is important to know that the equal sign here is not the same equal sign that we're used to in math. In other words, if I were to write x equals 5, in math, this would be equal to exact same thing as 5 equals x, because if x is 5, then 5 is also x. But in programming language, equal sign is assignment. And what assignment means is that you are assigning a value on the right side of the equal sign to the left side, which has the name of the variable. In another sense, you see how that Frida Kahlo string is going inside the box? Frida Kahlo is the right side of the equal sign and is being assigned to name, which is the name of the variable on the left side. So that kind of takes, the ambiguity out of the equal sign in mathematics and computer science and programming in general. So that's that. Now you can have a variable called name. Let's break this down. Let's take this one level further, and let's say I want to have I want to have, I don't know, something that's built up of two words. I don't know. Let's say, okay, let's fruit equals orange, and then you have a variable called form, and in this form, it comes in the form of juice. So if I were to console.log, or using the magical kind of command that prints this to my console, I could say fruit. And I could say, we could run this, and it would say orange. It's a really nifty trick. You can just use a plus sign to add two different strings together, and it'll be orange juice. That's pretty cool because you can join two different words or two different sentences with a plus sign. Now, this string is not really the only kind of type of variable that we can have. And I want you to get used to the idea of data types. And don't worry if it's not in the slides; it's in the notes that I put together. Data types are crucial in programming languages. That's how programming languages understand what kind of data we're feeding to them, what kind of data they're supposed to be working with. Like the computer language is not smart enough to figure out, oh, am I dealing with a number? Am I dealing with an object? Am I dealing with a string? What am I dealing with? So you need to tell it, hey, this is a string. Hey, this is a number. And so these are different data types. They're referred to as data types. String is one data type. Number is another data type. So, for instance, we have a variable called age, and we store the number 30 inside of it, and we can depict it in programming language in JavaScript as this. So you can see how I'm not putting quotations around 50. And this essentially is enough for us to tell JavaScript, hey, you're dealing with a number, take it as such, right? So I'm going to add another I'm going to be adding another thing, let's say another variable called 10 years from now equals age plus 10, right? You can see that age is of type number. 10 is also a type number because we're just putting the number out there with no quotation marks. The computer understands that you're giving it a number. So if I want to print out to my screen and do console.log age, it will print out 50. And if I console.log 10 years from now, it will print out 60. Right over here. So you can see how something like a plus sign that we use to add fruit and form and create orange juice is used between two numbers, and now what it does is actually add two numbers. This is, again, good because JavaScript is high level enough that it understands that if you're adding two variables of the type number, we actually want to add the digits, the number values of those. And when we are adding two different strings to each other, we want to kind of join them together. And that's good. That's what makes JavaScript easy to use and understand and kind of ramp up to. So that's numbers. Let's move forward to Boolean. We talked about how computers are constantly resonating between 0 and 1, between existing and non-existing. A very crucial data type that we will be working with throughout our class is called Boolean. And Boolean is a data type that, unlike strings and unlike numbers that can take any value at all, they only take two values. They're either true or false. And that's great because we can use this very basic construct and create very kind of intricate logical structures out of this. Let's think about it this way. I'm going to write a program that takes me from here to the subway station. I live on 40th Street in Sunset Park, Brooklyn, and the stop is on 36th Street on 4th Avenue in Brooklyn. So I'm going to say start walking. I'm going to write a program on a very high level human language. I'm going to say walk south on 40th Street. When you get to 40th Street, look to your left. Do you see the numbers increasing? If it's true, then that means that is south, and we don't want to go south. So make a right on 40th on 4th Avenue. Keep walking and check the number of the streets. Is it 36 yet? No, it's 39. Keep walking. Check the number of next block. Is it 38? Is it 36th Street? No, it's not. It's 38. Keep walking, so on and so forth until we get to 36th Street. So you can see how we only using Boolean as a control kind of apparatus, as a logic creating apparatus, we got from home to the subway station. And when you think about navigation in GPS and stuff like that, that doesn't really require us to roll up huge maps on the table and drop pins to figure out how I can get here on a road trip to Boston, and Google Maps does it for you. This is essentially the underpinning of how routing algorithms work for you. So Booleans are very simple, yet very, very powerful. So I'm going to create a Boolean variable called hungry true, var or variable thirsty equals false. And that's about it. That's the only two values that these two can get, right? Let's create another one. Have I reached 36th Street equals false, going back to the example that we created. I want you to take a moment and think about the way that I'm naming my values here and how I'm constructing these names for these values. It is important to know that when you're creating a name for a variable, you cannot use spaces and you cannot use dashes. So if I want to create if I wanted to create a variable name that is comprised of more than one word, I can't just say, have I reached 36th Street? It doesn't work that way because the JavaScript interpreter looks at this and it starts parsing every word as a different variable, and it gets confused really fast. So yes, it is great practice to have your variable names be very telling of what they actually contain. Think about when you're moving from this house to another house and you put everything in boxes and you don't label your boxes at all. Think about what the hell you're going to go through when you're unboxing your things, right? Or if you label the box of your, I don't know, underpants with the letter S, you know, and you'll be like, oh yeah, I remember what this means. No, you won't. When you move and you get you get the box, you want to know what's in it. So you want to be descriptive. So in another sense, if you want to create a variable, look at the box and think about what it is that it stores. Be descriptive. It's fine. It's fine to have long variable names. It's fine to be like, have I reached 36th Street? Because when you're looking at the program, you will be more kind of prone to understanding what you have written much easier. So then what do we do? What do we do? We can't have spaces in our program. There's this practice called camel casing, which starts like this. This is a variable that I am writing. Now I spell writing wrong all the time. That I'm writing on my screen. So you can see how I am conjoining different words together, and it stores a string hello. But I'm using a convention, and the convention is start small. The first letter is small. As you move to the second word, you capitalize the first letter of the second word, and then you move forward. So variable comes with capital V, that comes with capital T, and so on and so forth. This is called camel casing. You also notice that I am putting notes inside of my code using 2 forward slashes, and the 2 forward slashes denote a comment, and these are the lines that are not going to be executed by the by JavaScript interpreter and are going to be only meant for human eyes. So you can keep writing comments like, oh, hi there, and the computer won't run it, will dismiss it because it starts with 2 forward slashes. What if I wanted to create comments that are more descriptive and span more than one line? I can start typing /*, go another line down, and close it with */. And here I can write, this is a multi-lined comment, and it would also serve the same purpose. So we went over strings, we went over numbers, we went over booleans, we went over comments, and the nomenclature that we can use to kind of create our program. So let's move forward to objects. So let's move forward to arrays. Arrays are yet another data type that we use in our programming language. And arrays are essentially a list of things. Whenever you think about arrays, just think about shopping carts. Just think about shopping lists. Think about to-do items. And these are a enumerated list of different things that you put together and you call it a variable and you use it for different things, right? So, so for instance, here you have a to-do list and it's called do the dishes, write some code, draw some sketches, and then play some games and whatever, right? So let's see how this actually works in a programming language. So let's call this to-do list. This is how a array is made known to JavaScript with angle brackets. So I'm going to create a variable called to-do list, and I'm going to put it equal to open and close angle bracket. The minute I do this, the computer understands, okay, I am dealing with a list here. In this case, the list is empty. Now let's start adding some stuff to it. And I'm going to be adding instructions, and instructions are by nature words, and words are strings. So building on the knowledge of strings that we have up here, which we can denote strings using single quotes, we're going to be putting together a bunch of strings and representing this as a list that is enumerated and has indices stored internally in JavaScript. So we can say the to-do list is shop, comma, is important. So first item is done. Let's move on to the second item. Shop, wash clothes, drink beer. That pretty much sums up my life. Except for shopping, but maybe groceries. I don't really shop much outside of that. Yeah, you have it. Now you have a to-do list, and your computer understands that you are giving it a to-do list, and you can print it on your screen as such. You can say console.log a to-do list, and it will spit it out for you. You have a list of things. If you think about it, your list of emails in your email client is a list. The list of friends in your whatever social network you use, or if you don't, that's another list. The list of all the, I don't know, the books that you've put together is another. Everything is list, and it's very powerful to be able to use these kind of data structures to convey meaning. Now, these are enumerated, and I mentioned that they're enumerated. What does that mean? That means that the computer keeps track of the index of each and every element that is put inside of this array. And unlike human beings, computers start counting from 0. They don't start at 1. So if I want to have like 10 things, I don't start from, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But me being the computer, I start from 0. I do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So what if I wanted to print out the first item inside of my to-do list? What would be the index of the first item in my to-do list? It would be 0, right? So instead of 1, it's 0. So if I want to, I can console.log first, I can console.log to-do list using the same notation of angle bracket of no, these are not angle, but just like straight up brackets. I can pass in the number 0, and that will essentially tell the computer to print out the thing that is stored in index 0 of my list, which in human language would be the first. So always think about it this way: the first thing in your array is stored with a index of 0. You might ask, then why are we not seeing these indices visibly? That's because, again, the computer has made this abstraction for us that it automatically manages these kind of indices, and you don't have to worry about the enumeration and the number of index that you're kind of putting in there. That takes care of that. It is important to know that arrays have a property called length that also show you how many things are stored in that list, which is pretty handy. So you can type in, I want to see the length of my array, and it would show you something like, okay, there's 3 things. So there's shop grocery, there's wash clothes, and drink beer. That does it. It's 3 things. So I will be posting good resources that can ramp you up in JavaScript right after class, again, either today or tomorrow. I have also included a link for readings on Mozilla Developer Networks for JavaScript that you can read up on. And there are many other really good resources, such as Code Academy, which I will be posting here, Code Academy, which I'll be posting here in a little bit, that essentially give you an interactive learning experience for JavaScript that you can use. JavaScript.com recently launched, and it's really cool, very easy to use. It kind of takes you forward. Learn JavaScript. I'm going to write this like here. You can use this to get much better and more familiar in navigating your kind of the pathway of turning your ideas into code. Code Academy is fantastic. I am also here, whatever kind of questions you have. There's no such thing as a stupid question, so email me or any other means of communication. I'll be more than happy to answer any questions. Not much left. I guess it's Actually, maybe a tad left. Only a few slides. We have only 4 minutes. I would like to maybe ask Tony if it's good to go over these slides, or maybe we should cut it off here and pick up where we left off next week. Tony? Hello? Anyone? Okay, all right. So we're gonna go over this real quick. So in the same manner that you have lists that are enumerated by your computer and are called arrays, and they go from index 0 to however number of elements that you're storing in your list, you have another type of list that allow you to assign keys for those values. So think about objects, and these are called objects. Objects are key value pairs that we can use to describe a collection of things. And they're similar in certain ways with arrays, but they're more descriptive in the sense that the key for getting a value inside of an array is the number that is stored internally in your computer. But in the object, you actually can assign it a name, and it becomes much more robust and verbose. So for instance, I can have a variable called ID card, and my ID card would be equal to an object. And it's important to note that objects are created with curly braces, whereas arrays are created using square brackets. So ID cards equals open and close curly braces. What am I going to put in this thing? I'm going to say first name colon, not equal, but colon, money, comma, move forward. So comma is similar in both arrays and objects. Last name is Nilciani. Age is 28, which is a number, and so on and so forth. So you can see that objects are essentially keys, values. Depending on what type of value you have, you might have a number value, you might have a string value, or is tired, is false. You might even choose to have a Boolean value, and then you can print this console.log ID card, and hopefully it'll print it for us. Print it. Yes. So it prints it as object, age is 28, whatever, so on and so forth. And so remember how we accessed the index 0 of to-do list and we printed it on the screen? You can use the same methodology of using square brackets to access anything outside of inside of an object. So if you have ID card, you can use square brackets and say, give me the value of is tired of my ID card. So console.log. Actually, maybe let's call this person, because ID cards don't really talk about people's status of being tired or not. This is me making up things on the fly. So person is tired. It will print out false. Oops, reference error. What am I doing wrong? This is person. This is person. Run it. Is tired. This is tired. Is tired false? Oh no, okay. No, this was another error. So is tired is false, as you can see. You can also use, like for instance, first name. And first name will spit out Mani. All right, so I need to wrap this up real quick. So I'm going to be kind of jumping over the next few slides, and then you have the Yes, semicolon. Oh, semicolon is actually wrapped in the next line. Thank you for pointing that out. Yes. You always want to leave your semicolons in. Otherwise, your computer will be like, oh, what the hell are you talking about? You didn't finish your previous sentence. How am I supposed to know where the next sentence starts? So always end your sentences in code using semicolons. The next example is kind of a control structure, which is if and else. So in the same way that I described your passage from home to a train station, you have this notion of if and else. So your computer can check for a specific condition and can take a specific action based on that specific condition and another act if otherwise. So you can have something like, if person is tired, console.log, get some rest. Else, meaning that the person is not tired, and this is where the power of booleans becomes so apparent, because is tired can only be false or true. Else, that means if the person is not tired, then you can console.log. Good for you, in a very passive-aggressive manner. So when you run that, you see it says good for you because I'm not tired. If I change that to true, however, it says, oh, get some rest. So this, as simple as that, you can see that the flow of the program enters the if-else condition. If it's true, it'll go one way. If it's false, it'll go another way. Now let's talk very quickly about functions. Functions are things like factories that take input and turn them into output. For instance, in the case of P5.js, when we had things like rect is a function because it takes certain inputs and it outputs a rectangle for you. So rect in that case is a rectangle creating factory. So it's a function. Let's see what it means. You have a function called add. It takes two inputs, 2 and 4, and it spits out 6. As simple as that. If you have any memory of how f of x in math would work, you could relate that. You pass a value of x to a function, and it'll give you a value of y. So in this case, add function takes 2 inputs, and it gives you the sum of both of those things. You might have another function that reverses a string, like you can feed it red room, and it gives you murder. This is it's not named correctly. The function is called add, but I was meaning to make that reverse. But anyways, this is just to illustrate that functions take inputs, perform certain things on it, certain acts on it. It massages your input, and it turns it into an output. And it's up to you as a programmer to write your function. You could write a function that draws a constellation of stars, and then you can use it later on. In the same way that the function rect draws a rectangle for you on the screen. Now someone, the programmer of P5.js library, has written that function somewhere, and it has actually provided that for you so you can use it. If you follow the JavaScript tutorial that I added to the rollup, you will be much more familiar with all these concepts really quickly. All right, so for next session, I want you to start thinking about a procedural work of art and break it down into multiple steps. I want you to be a soloist for a week. I want you to be the programmer who wants to write a program that takes care of grading papers for a class, who writes pseudocode prior to writing actual code. I want you to think about a procedural work of art that you would like to create using inspirations from analog and non-digital procedural works of art that I showed previously, and compile one or more set of instructions for creating artworks. And we would take those and we would turn them into programs. So you will see that you can take the first step towards being a programmer, think procedurally, And then you can see that the next step is learning the syntax for translating that procedural thinking into actual machine-readable code. So this would be our kind of passage from procedural thinking to writing computer understandable procedural code. So that's your assignment. If you have other ideas, if you have developed other ideas, and if you want to talk to me about customizing your assignments for you, I'm more than happy to do that. This is a class for you, and I'm hoping to be kind of making it more and more useful for you. So if you have certain needs, if you have ideas, if you have feedback, if there's anything at all that you want incorporated in the class, please do let me know. Other than that, the more time you can take to sort of familiarize yourself with the concepts of JavaScript programming through these two links that I have added to the roll-up, the more the better. Take as much time as you can going through these tutorials just to understand the syntax, because the concepts are not complex. The concept of, oh, I want to have a container for data, and I have different types of data, that's not a hard thing to grasp. The more and more I realize that when learning programming, the daunting part is actually the syntax. When you see things that you're not used to, your eyes are not used to before. So looking at those examples, going through those tutorials will help you familiarize with those so that you can get over the hump of syntax easier. In the same way that when you get over the kind of the barrier of syntax in natural languages, you become a lot more fluent in speaking that language. Computer programs are not different than that. So this is basic code examples, and yeah, that wraps it up for this class.
Can I ask you something?
Please.
Can you go back to your JS bin where you had the code you were writing? Okay. Two questions. First of all, the first line when you have variable name Frida Kahlo, does it make the Frida Kahlo is a string, right?
True. Yes.
So why is it in like double quotation when orange and juice are in? You see that? Does it matter?
It does not matter at all. So that's a so you can clone your. It does not matter at all. I'm going to write a note here. Single and double quotes can be used interchangeably. However, that's to denote strings.
Okay. And one more question. When you made can you scroll down?
Yep.
When you made the object, when you had like name, last name, and when you did the console log, the order of when it was printed, the order was different.
Yeah.
So you had first Moni, last name Luciani, age 28 is tired true, and then when you printed, it like put the age first, and then does it like do it alphabetically, or why does it randomize when you have a different order when you were writing it down?
That's a very very good point. If you're concerned with the order of the elements that you're storing in your data structure, always use arrays, because arrays always observe order. Objects, however, don't, because you don't really need order in objects, because you have a key using which you can get the value that you want. Right?
Okay.
You have the key first name, you have the key last name, and you can simply use them using the square bracket notation to get the value out of your object, right? So they're not ordered in the same way as arrays. That I'm going to write this here. If you are dealing with data that is order sensitive, use arrays. Objects do not store order.
So the order that it gets printed out, what is the order? What is the order that object is concerned with? It's like random?
I don't, you know, I actually, that's a good question, and I don't have the answer for that. I don't know how internally JavaScript takes care of that, but taking a quick look at it, it might be that it sorts it with based on the variable type. For instance, age is number. It might like spit out all the strings first, and then you know, and then numbers. But the entire raison d'être of objects is that so you don't have to worry about order at all. You just put whatever value you want with a key inside of that object, and it will just store it for you, and you can access it at any time using the key.
Okay. Got it. Thank you.
Yeah, you're welcome. So objects are collections of keys and values. So here you would have var person, var object equals key, oopsie, key value, just to illustrate what I mean by key values. All right, any other questions? All right, have fun filling with things, playing around, ask a lot of questions. I'm more than happy to geek out on your questions and have conversations outside of class. And there are some readings. They're really easy reads. They're not like theoretically challenging or involved readings at all. They're fun. Hopefully, those will also create a you know, a framework for our discussion. And I'm open to questions still. You're most welcome. Tony, you're there? So if he's not there, then it's safe to assume that variable is Tony there equals false, right? And yeah, I don't know if I can wrap this up. If Tony needs to do something and stop the class or something, but let's see if I can. You know, I think that's it. I think you guys have all the material, and yeah, stay in touch.
Okay. Thank you.
All right. Yeah. Have a good day, and enjoy the rest of your weekend. See you next week.
Thank you.
Bye.
Thanks. Bye.
Of course. Bye.